Now we will discuss about the integration waveforms through RC circuit. Our aim is to find the frequency range for which CR circuit acts an integrator. How we have to write? Once you have to see the circuit diagram. In differentiator we are taking the output on resistor. In integrator we are taking the output on the capacitor. Why? There is a formula is there. E output is equal to 1 by RC into time integral of the input. When RC is very large, 1 by RC it will sum, small value it will come. Therefore, E output is directly proportional to time derivative of the input. Time derivative of the input. Clear? Now we will see the circuit diagram. This is the signal generator, function generator positive and function generator negative we have to take. Right? Function generator positive to, now you will see, function generator positive to resistance one end I am giving this, right? Next resistance other end to, resistance other end to CRO, one is CRO, another one is capacitor, another one is capacitor I am giving. How many is there? 3 is there here. So once you have to see resistance one end, CRO probe end and capacitor end. Capacitor other end we are going to connect the ground. Function generator ground we are going to connect the ground. CRO ground also we are going to connect the ground. This is the circuit. Once we have to connect the circuit, we can apply the first 100 Hz frequency we are applying. How much frequency we are applying? 100 Hz frequency I am applying. What is the waveform? That input waveform is square waveform we are getting on the CRO. Input waveform is square wave. Now, there we are decreasing the frequency. Here you have to increase the frequency. Suppose 200 I have to take, 200. So 200, once you have to see, this is the 2 into 100, 200. How the signal is changing? Waveform is changing, correct? Now 300 I am applying, 300, 300. Clear? Waveform is changing. Which waveform it is? So waveform maybe it is coming another waveform, shape. Now 400 you have to see. Waveform is changing now. Now you have to see 500. 500 you have to apply. Waveform is changing now. Which waveform it is? It is exactly rectangular beam. Once theory we know, if you have to take the square waveform, you have to take the square waveform, right? Input is square waveform. Now you change the output. While changing the frequencies, we are getting the output is, which output we are getting? Triangular output is getting. According to theory, we satisfied this one. Square input we are giving. While changing the frequencies, 100, 200, 300, 400, 500 and so on. Up to the within the range it is coming. It is the range 100 to 500 only we are getting here, integration circuit. In the range of RC circuit acts as an integrator in the range of 100 to 500 Hz frequency. So this way, that's why from theoretically what we learned, in the same way experimentally we are also getting. Suppose you have to see, this is the square beam. Now while changing the frequencies we are getting a rectangular beam, triangular beam. So sorry, triangular beam we are getting. Now once you have to see, while changing the frequencies we are getting the square wave into triangular form. So that's why in the laboratory, whatever the theory we are learning, in the laboratory we are practicing whether theory is executing or not, we will see. Correct? Okay. Thank you.